Hello friends, welcome to our channel Knowledge Amplifier. So in this particular video, I am going to discuss one very interesting concept related to validation. That is where the model which you have trained using the data which you have, how much accurate that is. Okay, one kind of that parameter I am going to discuss today, right? So all the data which I am going to use in this particular video will be provided in the description box or in the comment section. If you want, you can go through that. So first, CLC clear all, close all, warning off, as you generally write. CLC to clear the command window, clear all is used to clear the workspace, previously used variables, all those things. Close all is used to close the figure window, and warning off is used to suppress all the warnings arriving in the programming part. Okay, now what is the data set? Let me just discuss about that little bit. So here I am reading one particular data set M. Okay, M.txt is present. Let me just run this particular piece of code, and here let me write M. Okay, and see there are basically 4 columns: var1, var2, var3, var4. Okay, all 4 are basically, you can see, continuous data. There is nothing like categorical data present in this case, right? Now what is this? What are these values? What are the significance of these columns? Let us try to understand. The var1 is basically indicating the time. var2 is basically indicating the x coordinate value. Okay, var3 is basically indicating y coordinate value, and var4 is basically indicating amount of pressure at that particular instant. So basically this data set is nothing but some features or some data points, we can say, while writing the character M. Okay, when you are writing any character, that time is required. Okay, at each time, what is the x and y coordinate of the point using which you are writing, and how much pressure you are giving, that is basically loaded in these 4 variables. First one is time, next one is my x coordinate value, next one is my y coordinate value, and last one is the amount of pressure. Okay, so x coordinate, y coordinate values are stored in var2 and var3. So if we simply plot var2 in x direction, var3 in y direction, we should get the corresponding shape. So I am using plot m.var2, m.var3, because using dot we can extract the table columns. Okay, and see, you can clearly understand this is M. To observe in a better way, we can give axis equal, and let's run this particular code once more, and you can clearly see that this is nothing but our English alphabet M, right? Then what we are doing, we are reading similar kind of data present as text file in the current directory. Okay, now this time it is J. Okay, and we are plotting our J variable also, giving axis equal in a new figure window. Okay, similarly like that sort, I am plotting V. Okay, where the handwritten digit V is present. What is the time at each instant, at those time instant, what is the x coordinate, y coordinate value, and moreover, what is that? The last feature is how much pressure is appearing while writing, and I am plotting the second and third feature, which is x coordinate and y coordinate, and giving axis equal. So these 3 are my major data. Let us just run this particular sector. Code will be posted in the description box or in the comment section. No need to worry about the code. So you can see this is our English character M. This is J. See, this is the body part, and this one is the top circular part present in the character J, right? And this is our V. Okay, right? Okay, all right. Up to this, I hope it is clear to you. Now we cannot simply pass these values like the raw format for training. We need to extract certain features. Okay, a feature is simply a value calculated from a signal. That signal can be normal one-dimensional signal, maybe audio signal or something like that sort, or that may be images, or that may be videos. Okay, whatever, right? So this step is for feature extraction from this particular signal. So obviously, if you observe these 3 handwritten characters, you can understand there are some important features we can easily extract from this particular data. What is that? Obviously, one can be aspect ratio. Okay, height is to width. Okay, that is max value of y minus mean value of y divided by max value of x minus of mean value of x. Okay, that is nothing but height. Height is what? Max of y minus mean of y. Width is nothing but what? Max of x minus mean of x, right? So if you take this ratio, this is called aspect ratio, and aspect ratio for m will be differing from j because j is tall. Okay, right? But whereas our m is kind of square shape. Okay, the span along y direction is almost equal to span along x direction, but for our this particular character j, you can understand this is tall, that is in y direction the spread is more compared to spread in x direction, right? Similarly for v it will be different, right? Then one more thing can be considered as feature, that how much time it is taken for writing these characters. Okay, the timing required for writing the character m will be differing for the timing required for writing other characters like j or v, right? So obviously, as you know, we have this timing feature as first column, so we can extract this easily. So duration for m, duration for j, duration for v, all this, duration for m, duration for j, duration for v, all these things we can calculate. If you just check our m data, you can see the timing is starting from 0 and it is going to this particular value. So duration is nothing but the last value, because for the first value it is taking always 0, because at time instance 0 the character someone has started writing the character. Okay, so always first time value will be 0, so the duration is nothing but going to be the last value for the time column. Okay, so we can extract the end values for the var1, that is first column, we are extracting the last value. Okay, and this is giving us the duration required for writing the particular characters. Then what is that? I have told you aspect ratio. Aspect ratio can be interesting feature, and what I have told you the formula, here I am writing again, aspect ratio equal to max of y direction minus mean of y direction, that is nothing but this will be representing kind of height, okay, by max of x minus of mean of x. Okay, this is our aspect ratio. Now this max of y minus mean of y, instead of writing like this, you can use direct range function present in MATLAB, right? And y value is stored in our third column, right? First column is time instance, second column is x direction value, third column is y direction value, fourth column is basically the pressure. Okay, so we are calculating aspect ratio like this, range of y by range of x. Similarly for j, similarly for v, we are extracting. So using these two way, we are already achieved two very important features for our this particular signal. One is basically aspect ratio, another one is basically duration. Okay, now we can use these two to train our model. Okay, before going ahead, let us first consider one particular data set. So this one I have just shown you with respect to different three data set, m, j and v, okay, which is taken here. Now similarly like this, suppose from different people we have just taken writing for m, j and v variable, and we have already extracted the features like aspect ratio, duration and all this. Okay, and that is basically stored in my features.txt. Okay, this data also I'll be providing in the description box, no need to worry. Okay, so features equal to read table features.txt. Let us check how the data looks like actually. So if I just run features here, okay, let me turn on the, so here you can see that this particular features data is having basically three columns, where first column is indicating the aspect ratio for each character, second one is indicating duration, and third one is the what is the corresponding character. So we have extracted the aspect ratio and duration. First column is aspect ratio, second column is duration, and third column is basically the character which is written. Okay, you can simply check size of features and you will be getting 470 cross 3. Okay, there is 470 data present. Okay, right? Now this is nothing but now becoming one classification problem, right? Because we have the levels now we can classify, and this is not continuous, the outcome is not continuous, so obviously this is classification, not regression, right? Before going ahead to train our machine learning model, let us check that how the distribution looks. Okay, so the features, the input features we are going to plot, and we are going to group the features which are belonging to same class. Okay, so we are using group scatter, gscatter. Okay, we are plotting aspect ratio in x direction and duration in y direction, and Features.var3, this is basically our classes. Okay, based on this we are going to group, right? So let's give here one figure and let's run this particular piece of code. So basically you can see that this is our group wise scatter plot for our this 470 different handwritten digits, okay, which is containing V, J and M, right? Now in x direction we are plotting aspect ratio, in y direction we are plotting our duration. Okay, one thing is clear, I have told you, just recall, J shape is tall. Okay, in y direction span is much more than span in x direction, right? So obviously aspect ratio for J is going to be more. So you can see from the visualization also you can conclude that for these green data points the aspect ratio is going to very high value, and these green data points are actually belonging to the class J. Okay, but here basically our V and J are placed in a closed area, that is overlapping each other, these two features. So obviously using these two extracted features, one is aspect ratio, another one is duration, it is difficult to train a good machine learning model, because here you can see some overlapping is happening, but still we will try to do that. Okay, so here observation from this particular visualization is, it is not possible to make a reasonably accurate model that uses these two features to distinguish between these three letters, because we have seen overlapping is there. But still let us have a try. So first we are going to train our KNN model using fitcknn. As you know, we have to pass the features and what is our outcome, okay, which is stored, that is classes, output labels, which is stored in our last column var3. Okay, we are writing this, and then here I am taking one small test data set which is again having 3 columns. First column is basically our aspect ratio, second one is duration, and third one is actual labels. So this one we can use for validation. Okay, so what I can do here, I am training my KNN model with default value of k. As you know, for MATLAB the default value of k in fitcknn is 1. That is one nearest neighbor it is going to implement. Okay, right? And then here we are predicting that. First we are passing the model and then passing the input feature from test data, because no need to pass the label, that is last column. So what I am doing, all rows and first 2 columns I am passing. And observe, in observation matrix what we are storing, we are storing first the actual labels, that is the last column of my test data, which is storing the actual labels of the test data and what our model is predicting. Okay, so let's run this particular piece of code. Okay, and let's check the observation. Yep, so we have taken up to here. Let us check our observation. So this particular, for the observation, as you can see, first one is storing actual labels and second one is storing predictions. Okay, right? So if you see that J matching, M matching, V matching, this one matching, this one matching, VJ mismatch, test actual label and prediction mismatch. Okay, no problem. Here matching, here matching, here matching, here matching. Most of the things are matching with k value 1 itself. But logically, if you think, we should not take k equal to 1, because if you recall our discussion related to k nearest neighbor, I have told you if k value is very small, like here k equal to 1, that time it is highly affected by noise or outliers, and you can see that this particular data has some outliers, right? If you check, this particular rate point is coming, actually it seems it is coming under area of this green region, right? Similarly, this particular green data point also coming under this blue region. Okay, so basically what is happening, that outliers present, and to overcome the effect of outliers we need to increase our k value, right? So let's go through that. And here what I am doing to reduce the effect of outlier, I am increasing my number of neighbors from 1 to 5. Okay, fitcknn features var3 number of neighbors 5, and then again applying prediction and calculating the observation. Okay, right? Now let's run this particular piece of code. So up to this we have computed. Let us check the observation. So J match, M match, V match, J match, MV, this one is mismatching, VJ, this one, two mismatch happening. Okay, actually with k equal to 1 we are getting lesser amount of misclassification, but whereas k equal to 5 is generating more number of misclassification. But no problem, logically this should be the value, because you can see that there are lots of outliers present, right? Okay, this might happen that for this particular test data it is happening like this, but generally as outlier is present, so it is suggested not to take very less k value. Okay, now let's go to accuracy, which is our today's actual discussion. Okay, so accuracy, if you check, very simple, just we will compare our prediction with respect to our test data actual level, and if match then correct, if mismatch then wrong, right? So is correct we are storing in this particular array, we are comparing prediction with our last column of test data, which is storing actual levels. Okay, we are converting to string because those are categorical, and directly categorical comparison using equal to not possible. Then we are computing accuracy, which is sum of is correct, okay, divided by total number of data points present in the particular test data, and number of data points present in the test data is nothing but number of data points present in is correct, right? Obvious. So using this we can calculate accuracy. So is correct will be 1 if prediction and test data actual level match, is correct will be 0 if test data and prediction mismatch, right? If you want to calculate misclassification rate, then just take complement of is correct and apply the same formula. Okay, right? Let us run this particular piece of code and let's check the accuracy and misclassification. So it will be taking some time. Accuracy is 0.8, misclassification is 0.2. As we have seen also that 2 misclassification, 8 correct classification. Our test data is having size 10. So 80% accuracy, 20% misclassification, right? But this one are giving a single value. Okay, rather what we can do, we can plot confusion matrix. What is that? Let me discuss. So here confusion matrix in MATLAB, the syntax is confusion chart. Okay, first input parameter will be y_true, that is vector which is basically known classes, actual levels, and next one is prediction, what our model is predicting. In new figure window I am plotting that confusion chart testdata.var3. var3 is nothing but what? Correct, actual levels of my test data, and next one we are passing prediction. Let's run this particular piece of code and let's check how it is showing. So this is our confusion matrix. What this one is indicating? See, JMV. Similarly in y-axis, JMV. This is true class, this is predicted class, right? See, J, here also J, here also J. That means there are 4 J which are classified properly. Okay, right? Then here this one is blank, this one is blank, no need to worry. Okay, this one is also blank, no need to worry. Coming to this one, true class is M, predicted class is M. That means prediction and true class matched 3 times for M class. But here one is coming, true class is M but predicted class is V. Okay, that means actual class is M but prediction, our model is telling no, the actual class for that particular test data is V. Like that, how many scenarios are appearing? Only one case. Okay, this one is indicating, see, true class V, predicted class J. This is indicating true class for our one of data point is V, but our model is predicting that as J. Okay, this is misclassification. This one blank, leave it. This one true class V, predicted class V, that is correct classification. So correct classification C is stored diagonally. If you observe J, M, V, V, that is true class, predicted class same. And here if you see, misclassification is this one and this one. Okay, right? Two misclassification. I hope you have understood this. This is one very interesting thing, confusion chart, which is basically generates confusion matrix. And what is confusion matrix? I hope it is clear to you. This is all for this video. I will continue this kind of discussion in my upcoming videos. Till then, stay tuned. Happy machine learning. Thank you.